Hey there! How's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Picture this. It's 3:17 in the morning. Hawaii time, June 15th, 2025. Most of the world is fast asleep, but up on Mauna Loa, one of Earth's most isolated places, Sarah Chen is wide awake. She's staring at her computer screen in the dim glow of the Asteroid Terrestrial-impact Last Alert System observatory, and something is very, very wrong. Before we continue this journey, tell us where you're tuning in from and if this story resonates with you. Make sure you're subscribed, because tomorrow I've saved something extraordinary for you. Sarah has been tracking asteroids and comets for 7 years. 7 years of routine observations, catalogue updates, and orbital calculations that follow the predictable dance of celestial mechanics. Tonight should be no different. She's updating the trajectory for comet C/2017 K2, a comet they've been watching since its discovery 8 years ago. The locals call it Atlas, after the mythical giant who held up the heavens. But here's the thing about space. It's supposed to be predictable. When you're dealing with objects millions of miles away, traveling in paths carved by gravity over billions of years, surprises don't happen. They can't happen. Except tonight they are. Sarah runs the numbers through her computer for the 3rd time. The orbital calculation software, the same program that's never failed her, keeps spitting out the same impossible result. According to her data, Atlas has changed course. Not by much, just 0.003 degrees. That's like shifting the direction of a bullet by the width of a human hair. In space terms, it's nothing. In Earth terms, it's everything. Think about that for a second. This comet, this ancient ball of ice and rock that's been following the same path for 12,000 years, has suddenly decided to take a slight left turn. Sarah's hands are actually shaking as she reaches for her phone. Hey, Dr. Martinez? Sorry to wake you, but I need you to look at something. Right now, within an hour, the mountaintop observatory is buzzing with activity that hasn't been seen since the facility opened. Dr. Elena Martinez, the facility director, arrives still wearing her pajama top under a hastily thrown-on jacket. Behind her come 3 other astronomers, all looking like they've been dragged from their beds. Because they have. Show me, Martinez says simply. Sarah pulls up the trajectory model on the main screen. The beautiful, sweeping arc that Atlas should be following appears in blue. The new calculated path shows up in red. For most of the journey, they're identical. But there, at the very end, they diverge. The red line doesn't sweep harmlessly past Earth like it's supposed to. The red line intersects with a small blue dot labeled Earth, August 13th, 2027. You're not going to believe this, but Martinez's first reaction isn't panic. It's skepticism, complete scientific skepticism. Run it again, she orders. Different software, they do. Same result, different telescope data. They pull readings from the backup systems. Same result. Call Palomar. Call the Europeans. Call everyone. And this is where our story gets really wild, because Sarah Chen isn't the only person having a terrible night. At the Palomar Observatory in California, astronomer James Wu has been running the same calculations for 2 hours. He keeps getting the same impossible answer. In Chile, at the Atacama Large Millimeter Array, Dr. Carla Rodriguez has been staring at her screen since midnight. Convinced her equipment is malfunctioning, by sunrise in Hawaii, the impossible has become undeniable. 12 observatories on 4 continents have confirmed it independently. Atlas, the comet that was supposed to give Earth a spectacular light show as it safely passed by, is now on a collision course. But here's what's truly terrifying about this moment. Nobody knows why. Comets don't just change direction. They follow the laws of physics as religiously as the sunrise. Something made Atlas alter its course. And as of 6 a.m. Hawaii time, on June 15th, 2025, nobody on Earth knows what that something was. Sarah is now part of a group text thread that includes some of the world's most brilliant minds. And they're all asking the same question. How do you tell 8 billion people that they have 2 years and 2 months to live? Now let me walk you through what Atlas actually is, because understanding your potential destroyer makes this whole thing even more mind-blowing. This isn't some little space rock. Atlas is a monster, 100 kilometers wide. That's the distance from Manhattan to Philadelphia. Imagine Central Park, but instead of trees and lakes, it's a solid ball of ice and rock moving at 60 kilometers per second. That's fast enough to circle Earth in 11 minutes. This thing has been traveling through space since before humans learned to write, before the pyramids were built, before we figured out how to grow crops. Atlas has been on its journey since the last ice age, following a path so precise you could set your watch by it. Until now, the first photographs of Atlas were taken in May 2017 by astronomers at the University of Hawaii. Back then, it was just a tiny dot on their images, so far away it took months to confirm it was actually moving. They were excited, really excited. Atlas was what astronomers call a dynamically new comet, meaning it had never been close to the Sun before. It was a pristine time capsule from the outer reaches of our solar system, carrying chemical signatures from the very formation of our solar system 4.5 billion years ago. Picture the excitement in those early days. Here was a comet that would give us our best look ever at the original building blocks of our solar system. It was going to be the astronomical event of the decade when it swung past Earth in 2027. NASA was planning missions. The European Space Agency was designing special observation campaigns. Students around the world were writing thesis papers about what Atlas might teach us about the early solar system. Nobody was writing papers about what Atlas might do to the solar system. By 10 a.m. Hawaii time, the group of astronomers has grown to 37. The secure conference call includes voices from the International Astronomical Union, NASA, the European Space Agency, and observatories from every major spacefaring nation. The conversation has moved beyond, "Is this real?" to "What do we do about it?" Dr. Martinez, now fully dressed and running on her 4th cup of coffee, is coordinating what might be the most important scientific collaboration in human history. "We need to verify the trajectory change one more time," she says. "Triple-check everything. Then we need to figure out what caused it. And then..." She pauses and you can hear the weight of history in her voice. "Then we need to decide how to tell the world. Here's what they know for certain. Atlas changed course sometime between its last routine observation on June 10th and Sarah's discovery 5 days later. 5 days during which humanity went from being spectators to a cosmic light show to becoming potential victims of cosmic destruction. But here's what they don't know. And this is what's keeping 37 of the world's smartest people awake. What made it change course? Because the answer to that question determines everything. If it was a one-time event, maybe a collision with another object, or an unusual outgassing event from the comet itself, then the new trajectory is fixed. Atlas will hit Earth on August 13th, 2027 at 4:32 a.m. Greenwich Mean Time, and there's nothing anyone can do about it. But if the course change was caused by something ongoing, gravitational influences they haven't calculated, or continuing outgassing that's still affecting the comet's path, then maybe, just maybe, the trajectory could change again. Sarah, who started this whole thing by noticing some numbers didn't add up, is now working with a team of orbital dynamic specialists to backtrack Atlas's journey over the past several months. They're looking for the moment when everything changed. It's like cosmic detective work, following clues through millions of miles of empty space, to find the exact moment when humanity's fate was decided. "There," says Dr. Yuki Tanaka from the Japanese Space Agency, pointing at a trajectory model on his screen. November 23rd, 2023. That's when it happened. The room goes quiet. November 23rd was when Atlas made its closest approach to Jupiter, still 500 million kilometers away, but close enough for Jupiter's massive gravity to have an effect. They'd calculated that interaction months ago. It was supposed to speed Atlas up slightly and bend its path by a tiny amount, but not enough to matter for Earth. They were wrong. Jupiter didn't just bend its path, Dr. Tanaka continues, his voice tight with the implications. Jupiter's gravity, combined with outgassing from the comet, created a resonance effect. Small changes building on each other over 18 months until... He doesn't finish the sentence. He doesn't need to. By noon Hawaii time, the mathematical models are complete. There's no uncertainty left. Atlas will strike Earth's Pacific Ocean 600 kilometers south of Hawaii on August 13th, 2027. The impact will release energy equivalent to 500 million nuclear bombs exploding simultaneously. The resulting tsunamis will reach heights of 100 meters. The debris thrown into the atmosphere will block sunlight for years. Sarah Chen, who just 12 hours ago was doing routine observations, is now part of the group that must figure out how to tell the world that civilization, as we know it, has 2 years and 2 months left to run. But here's the most incredible part of this story, and why I wanted to share it with you. In those first few hours, as the reality of the situation sank in, these scientists didn't despair. They didn't panic. They did what humans do best. They started to plan. Even faced with extinction, they began calculating trajectories for deflection missions, evacuation strategies, and survival scenarios. Because sometimes, the most human thing you can do is refuse to accept the end of the world. The conference call that began with 37 voices now includes representatives from every major government on Earth. The conversation has shifted from what's happening to what can we do about it. And amazingly, there are things they can do. Not easy things, not guaranteed things, but possibilities. Real possibilities. As June 15th draws to a close in Hawaii, Sarah Chen is still at her computer, still running calculations. But now, instead of tracking a comet's path to destruction, she's helping calculate the trajectory for humanity's first serious attempt to move a comet. Because in the face of cosmic destruction, we're going to try something that's never been attempted in the history of our species. We're going to try to save ourselves tomorrow. I'm going to tell you about Atlas itself, this ancient wanderer that's become our potential destroyer. We'll journey back 4.5 billion years to witness its birth in the frozen darkness beyond Neptune and follow its incredible journey through space and time. You'll discover how this cosmic time capsule became our species' ultimate test and why understanding our enemy might be the key to our survival. Until then, look up at the night sky. Somewhere out there, moving at 60 kilometers per second, Atlas is approaching. And thanks to Sarah Chen's insomnia and some very wrong numbers on a computer screen, we know it's coming. Sweet dreams. To truly understand what's coming for us, we need to take a journey. Not through space, but through time. 4.5 billion years back, to a place and moment that would determine humanity's fate. Picture the early solar system, not the orderly arrangement of planets we know today, but a swirling chaos of gas and dust. The sun is young, violent, throwing off solar winds that could strip atmosphere from planets. And out there, far beyond where Neptune will eventually settle, in the frozen darkness 40 times farther from the sun than Earth, something incredible is happening. Here's what's wild about that time. Everything we see today, every planet, every moon, every asteroid, is just cosmic dust and debris slowly coming together. Gravity is the sculptor, pulling particles together grain by grain. In the inner solar system, where it's warm, rocky planets are forming. But out in the cold, beyond the frost line, something different is happening. Water freezes. Not just water, but methane, ammonia, carbon dioxide. All the gases that would be invisible vapor closer to the sun become solid ice crystals in this frozen realm. And these ice crystals, along with dust particles older than our planet, begin to stick together. Imagine snowflakes, but each flake is the size of a pebble, and they're sticky, really sticky. As they bump into each other in the darkness, they don't bounce apart. They cling together, building larger and larger clumps. Over millions of years, these clumps become boulders. The boulders become mountains. The mountains become something we would call a dirty snowball 100 kilometers across. This is the birth of Atlas. But here's what makes this story even more incredible. Atlas isn't just any old comet. It's what astronomers call a pristine object, meaning it's never been close enough to the sun to change. Think of it as a time capsule, preserving the exact chemical composition of that original disk of gas and dust that formed our solar system. Every molecule of water ice, every grain of interstellar dust, every trace of organic compounds, it's all still there, frozen and unchanged after 4.5 billion years. Now, let me tell you about the neighborhood where Atlas spent most of its life, because it's one of the most fascinating places in our solar system. It's called the Oort cloud, named after the Dutch astronomer Jan Oort, who first proposed its existence in 1950. Picture a spherical shell of icy objects surrounding our entire solar system, stretching halfway to the nearest star. We're talking about trillions of objects out there, some as small as houses, others as large as mountains, all of them leftovers from the formation of the solar system. They orbit so far from the sun that they're barely held by its gravity. 1 light year out, where the sun's influence starts to fade and the gravity of other stars begins to matter. For 4 billion years, Atlas lived in this frozen wasteland, following a lazy orbit that took millions of years to complete. The sun was just the brightest star in its sky, no warmer than any other distant star. Temperature out there? Try negative 240 degrees Celsius. That's so cold that air would freeze solid. But then, 12,000 years ago, something happened. Picture this cosmic game of billiards. A star, probably a red dwarf about 6 light years away, passed close enough to the Oort cloud to disturb the delicate gravitational balance. Not a collision, just the gentle tug of gravity across the vastness of space. It was enough. Atlas, which had been content in its million-year orbit around the sun, suddenly found itself falling inward. Not quickly, we're talking about cosmic timescales here, but inevitably, like a ball rolling down a hill that takes millennia to complete its journey. Now here's where the story gets personal, because the first human being to actually see Atlas was Dr. Robert Weryk at the University of Hawaii on May 27, 2017. He was using the Panoramic Survey Telescope and Rapid Response System, PANSTARS for short, scanning the sky for near-Earth objects. Just another dot, he said later in interviews. Moving so slowly we had to watch it for weeks to confirm it was actually a comet. But what a comet it turned out to be. As Atlas fell deeper into the solar system, closer to the sun's warmth, something magical began to happen. The surface ice started to sublimate, turning directly from solid to gas without melting. And as this happened, Atlas began to develop its signature tail. Here's the thing, most people don't realize about comet tails. They don't trail behind the comet like you might expect. They're blown away from the sun by solar wind, so they always point away from our star, regardless of which direction the comet is traveling. As Atlas approached, its tail grew longer and more spectacular, eventually stretching millions of kilometers across space. By 2021, amateur astronomers with backyard telescopes could see Atlas clearly. It had become what astronomers call a great comet, one of those once-in-a-lifetime celestial visitors that captures the public imagination. Social media filled with photographs of this cosmic wanderer, its tail streaming across star fields like a cosmic brushstroke. Dr. Chen, an astronomer at Beijing University, spent 3 years studying Atlas with every instrument available. It's like having a piece of the original solar system delivered to our doorstep, she explained to her graduate students. The spectroscopic analysis is incredible. We can see water vapor, carbon monoxide, methane, even complex organic molecules that might be the building blocks of life. What they discovered was astounding. Atlas wasn't just ice and rock. It was a chemistry set containing elements and compounds from the very beginning of our solar system. Nitrogen compounds that might have seeded Earth's atmosphere. Carbon-rich materials that could have been the foundation for life. even traces of metals that had been forged inside dying stars billions of years before our sun was born. Think about that for a moment. Atlas is carrying stardust, literally pieces of stars that lived and died before our solar system existed. It's a messenger from both our past and our cosmic origins. And now it's coming to Earth in the most violent way possible. But here's what makes the scientists studying Atlas both excited and terrified: its size. Early estimates based on brightness suggested it might be 50 kilometers across. But as better observations came in, that number kept growing. 60 kilometers, 80. By 2024, using radar observations and thermal imaging, they knew the truth. Atlas is 100 kilometers in diameter. To put that in perspective, the asteroid that killed the dinosaurs 66 million years ago was about 10 kilometers across. The impact that created the moon was caused by an object maybe the size of Mars, but that was when Earth was still forming. In all of recorded human history, nothing this large has ever threatened our planet. Dr. Maria Santos, a planetary scientist at the European Space Agency, spent months creating computer models of what Atlas actually looks like. It's not spherical, she explains. It's more like a cosmic potato, lumpy and irregular, probably formed when smaller objects crashed together in the early solar system. The surface, according to spectroscopic analysis, is darker than charcoal, covered in a layer of organic compounds that have been baked by cosmic radiation for billions of years. But underneath that dark crust lies the real treasure, or the real threat, depending on your perspective. Pristine ice, Dr. Santos continues. Water ice as pure as anything we've ever discovered, mixed with frozen carbon dioxide, methane, and ammonia. It's like a perfectly preserved sample of the primordial solar system. As Atlas continued its approach through 2025 and 2026, something remarkable happened. The comet began to change. The closer it got to the sun, the more active it became. What started as a barely visible fuzzy star transformed into one of the most spectacular objects ever to grace Earth's sky. By January 2027, Atlas was visible to the naked eye. By March, it outshone Venus. By May, its tail stretched across 30 degrees of sky. That's 60 times the width of the full moon. On clear nights, you could read by its light. Children born after 2025 grew up pointing at Atlas in wonder, not knowing they were looking at their potential destroyer. Astronomers around the world had never seen anything like it. This wasn't just a comet, it was a cosmic lighthouse, announcing its approach with a display of beauty that took your breath away. But beauty can be deceiving. Dr. Chen, the same astronomer who first noticed Atlas's course change, spent months analyzing what all that activity meant for the impact. Every time it outgasses, she explained to her colleagues, it's like a natural rocket engine. Tiny thrust but continuous. We had to constantly update our trajectory calculations because Atlas kept changing its own path. Here's what's truly mind-bending about this situation. Atlas is simultaneously the most studied object in human history and a complete mystery. We know its chemical composition better than some asteroids in our own neighborhood. We've mapped its surface features using radio telescopes. We've tracked every change in its brightness and activity level, but we still don't know exactly what will happen when it hits. Computer simulations suggest the impact will create a crater 30 kilometers across and 10 kilometers deep in the Pacific Ocean floor. The energy release, 500 million megatons, will instantly vaporize cubic kilometers of seawater. The shock wave will register as a magnitude 15 earthquake, off the scale of anything we've ever measured. But here's what keeps scientists awake at night. Those are just the immediate effects. Atlas is carrying something else in its frozen heart, billions of tons of water and organic compounds that will be scattered across Earth's atmosphere and surface. In the midst of destruction, it will be delivering the ingredients for new life. It's the ultimate paradox, explains Dr. James Morrison, an astrobiologist at Cambridge University. Atlas might destroy our civilization, but it's also bringing the chemical building blocks that could seed Earth's next evolutionary chapter. As August 2027 approached, Atlas dominated the night sky. Its nucleus, heated by the sun, glowed like a second moon. Its tail, now stretching halfway across the celestial sphere, pulsed and shimmered as solar wind sculpted the streaming gas and dust. People gathered on rooftops and in fields to watch this cosmic visitor in its final weeks. Some in terror, others in awe, many in a strange mixture of both. Because Atlas had become more than just a comet, it was a mirror reflecting everything we are as a species. Our curiosity, our fear, our incredible ability to study and understand even the agent of our potential destruction. In those final nights before impact, as Atlas grew from a point of light to a visible disk racing across the stars, humanity was witnessing something unprecedented in our history. We were watching our fate approach, understanding exactly what it was and what it carried, and preparing to meet it with everything we had learned in our brief but remarkable time as a species. Tomorrow, I'll tell you about the physics of how a comet changes course, the invisible forces that can redirect objects weighing billions of tons and turn a cosmic light show into a planetary threat. We'll explore the moment when Jupiter's gravity sealed our fate, and discover how many near misses Earth has survived that we never even knew about. How does something weighing 6 trillion tons suddenly change direction in the vacuum of space? How does a cosmic wanderer that's been following the same path for 12,000 years decide to take a deadly detour toward Earth? The answer lies in forces so subtle we can barely detect them, yet so powerful they can redirect the course of human history. Let's start with November 23rd, 2023. Picture Atlas, still more than 3 years from impact, sailing through space at 58 kilometers per second. To most observers, it's just another comet following a predictable path. But 500 million kilometers away, something massive is waiting: Jupiter. Now I need you to really visualize what 500 million kilometers means. That's about 1,300 times the distance from Earth to the Moon. At that distance, Jupiter looks like just another bright star from Atlas's perspective. But here's what's invisible and terrifying. Gravity doesn't care about distance. It just gets weaker. Think of gravity like ripples spreading out from a stone dropped in a perfectly still pond. Close to the stone, the ripples are huge, dramatic waves. Farther out, they're barely perceptible. But they never stop. They keep spreading, getting weaker, but never disappearing entirely. Jupiter's gravity works the same way, reaching out across hundreds of millions of kilometers with invisible fingers that can bend space itself. When Atlas passed Jupiter that November day, something incredible happened. Picture a bowling ball rolling across a stretched rubber sheet. Now imagine someone placing a basketball on that same sheet, far away from the bowling ball's path. The basketball creates a depression in the sheet, and even though the bowling ball passes nowhere near it, its path bends slightly as it rolls through the warped space. That's exactly what happened to Atlas. Dr. Yuki Tanaka from the Japanese Space Agency ran the calculations thousands of times, trying to understand why their orbital predictions had been wrong. "We knew Jupiter would affect Atlas," he explained to the Emergency Scientific Committee. "We calculated a minor path adjustment, maybe a few thousand kilometers difference by the time it reached Earth's orbit. What we didn't account for was the resonance effect. Here's where the physics gets really wild and why this disaster was so impossible to predict. Atlas isn't just a solid ball of ice and rock. It's what astronomers call an active comet. As it gets closer to the sun, the ice on its surface begins to sublimate, turning directly from solid to gas. This creates jets. Think of them as natural rocket engines scattered across the comet's surface. Now, imagine 50 fire hoses all pointing in different directions, randomly turning on and off as the comet rotates. Each jet provides a tiny amount of thrust, barely measurable individually. But they're continuous, and they're persistent, and they all add up over time. Here's the crazy part. When Atlas passed Jupiter, These outgassing jets were in perfect sync with Jupiter's gravitational influence. Instead of the effects cancelling each other out, they amplified each other. It's like pushing someone on a swing if you push at exactly the right moment. A tiny force can create a huge effect over time. Dr. Elena Rodriguez at the Atacama Observatory discovered this resonance effect while trying to backtrack Atlas's path. It was like watching a cosmic conspiracy, she said. Every factor that should have been insignificant became significant. Every force that should have been minor became major. Let me give you an analogy that might help. Imagine you're trying to change the course of a massive oil tanker using nothing but a handheld electric fan. Impossible, right? But what if you could position that fan in exactly the right place, at exactly the right time, and keep it running for months? What if the tanker was moving through water that amplified your tiny force? That's what happened to Atlas. Jupiter's gravity provided the amplification, and the comet's own outgassing provided the continuous tiny thrust. Over 18 months, a course change that should have been negligible became catastrophic. But here's what really keeps me up at night. This isn't the first time something like this has happened. We just never noticed before because the consequences weren't coming straight at us. Let me tell you about July 19th, 1994. That's when astronomers got their first real look at what happens when gravity gets violent. Comet Shoemaker-Levy 9 had been captured by Jupiter's gravity sometime in the 1960s or 70s. But instead of a gentle course correction, Jupiter's tidal forces literally tore the comet apart. Dr. Eugene Shoemaker, one of the comet's discoverers, described watching through telescopes as 21 separate fragments crashed into Jupiter over the course of a week. It was like watching cosmic artillery, he said. Each impact created fireball explosions larger than Earth. The largest fragment, dubbed Fragment G, hit Jupiter with the force of 6 million megatons of TNT. The scar it left in Jupiter's atmosphere was larger than Earth and lasted for months. When astronomers calculated what would have happened if Shoemaker-Levy 9 had hit Earth instead, they realized humanity had dodged a bullet we never knew was coming. But that's just one example. The more we study orbital mechanics, the more we realize how many near misses Earth has survived without us ever knowing. In 1833, a comet now known as Biela came within 6 million kilometers of Earth, close enough that if it had arrived just 30 days earlier in its orbit, it would have hit us. In 1908, something exploded over Tunguska, Siberia, with the force of a nuclear bomb. We're still not sure if it was an asteroid or a comet fragment, but it flattened 2,000 square kilometers of forest. Here's what's terrifying. We only discovered most of these near misses decades after they happened. How many potential planet killers have we not noticed? How many more are out there right now, following paths that could change at any moment? Dr. Alan Fitzsimmons at Queen's University Belfast has been studying this question for 20 years. Space isn't empty, he explains. It's full of gravitational currents, debris fields, and objects we can't see. Every year, we discover asteroids that pass closer to Earth than the Moon. We find them after they've already gone by. The more we learn about orbital dynamics, the more we realize how chaotic the solar system really is. There's something called the three-body problem in physics. When you have three objects influencing each other gravitationally, their behavior becomes impossible to predict over long time periods. And our solar system doesn't have three objects. It has thousands of significant ones, all pulling on each other in an intricate dance of attraction and repulsion. Computer simulations running on the world's most powerful supercomputers can barely track all these interactions. Dr. Maria Holman at the Harvard-Smithsonian Center for Astrophysics runs models that follow the motion of every known object larger than 10 kilometers in diameter. The calculations are staggering, she says. We're tracking 5 million variables changing every second for billions of years. And even then, we can only predict with confidence about 50 years into the future. Beyond that, the system becomes chaotic. Tiny uncertainties in position or velocity grow exponentially until our predictions become meaningless. It's like trying to predict the weather, but instead of days, you're looking thousands of years ahead. This is why Atlas caught us by surprise. All our orbital calculations were based on a perfectly predictable universe, where comets follow nice, clean, elliptical paths. But the real universe is messier than that. It's full of subtle forces and complex interactions that can turn a harmless comet into a planetary threat. Here's the most unsettling part. Atlas's course change wasn't even that dramatic by cosmic standards. We're talking about a deviation of less than 1 degree over 18 months. In human terms, that's like a train being delayed by 3 minutes on a cross-country journey. Barely noticeable, except when the destination is Earth. Dr. Chen at Beijing University has been running simulations to understand what other objects might be similarly affected. We've identified 17 comets and asteroids that could potentially have their orbits altered by gravitational resonances with Jupiter or Saturn, she reports. Most would miss us by millions of kilometers, even with course changes. But 3 of them, she pauses, 3 of them could be problems. The scariest part? We won't know if any of these objects have changed course until they're already on their way to us. By the time we detect a course change, the physics make it almost impossible to change course again. Space is vast, but when you're moving at 60 kilometers per second, you don't have much time to react. Let me put this in perspective. Atlas will travel from Jupiter's orbit to Earth in just under 4 years. That sounds like a long time, but in terms of mounting a defense against a 100-kilometer-wide comet, it's barely enough time to get organized, let alone build and launch the kind of mission that might deflect it. This is why the discovery of Atlas's course change created such panic in the scientific community. Not just because it was coming, but because of how little time we had to respond. And because it proved that our understanding of orbital mechanics, our ability to predict cosmic threats, was fundamentally flawed. But here's something incredible that emerged from that panic. When faced with the ultimate test of our scientific knowledge, humanity didn't despair. We got creative. Engineers started designing deflection missions that had never been attempted. Physicists began calculating ways to use the same gravitational forces that doomed us to save us. Because if gravity could change Atlas's course once, maybe, just maybe, we could change it again. The race was on. Humanity versus physics, with the ultimate stakes and the ultimate deadline. We had 2 years and 2 months to rewrite the laws of cosmic mechanics, or learn to live in a world where Comet Atlas had rewritten them for us. Tomorrow, I'll take you inside those desperate final years as the world mobilized like never before. You'll meet the engineers designing humanity's most ambitious space mission, the planners coordinating the largest evacuation in history, and the ordinary people whose extraordinary courage defined our species' response to the ultimate crisis. June 20th, 2025. The day everything changed. At exactly 9 a.m. Eastern Time, President Sarah Williams stepped up to the podium in the White House press room. Behind her stood the leaders of NASA, the European Space Agency, and the International Astronomical Union. The room was packed with reporters who had been summoned for what the White House called a matter of urgent global importance. My fellow Americans and citizens of the world, the president began, her voice steady despite the magnitude of what she was about to announce. 5 days ago, our scientists confirmed that Comet Atlas, previously expected to pass safely by Earth, has changed course. It will impact our planet on August 13th, 2027. The silence in that room lasted exactly 4 seconds. Then chaos. Within minutes, every major news network was broadcasting live. Social media exploded with hashtags like Atlas and End of the World. The Dow Jones dropped 1,500 points in the first hour, then did something unprecedented. It shot up by 3,000 points as investors realized money might not matter anymore. But here's what's remarkable about that day. Within 6 hours of the announcement, every major world leader had committed to full cooperation. The United Nations called an emergency session China offered its entire space program. Russia opened its nuclear arsenal for peaceful purposes. For the first time in human history, our species was truly unified by a common threat. Maria Rodriguez knew none of this was happening when she got the call. She was in her office at Mexico City's Emergency Management Center, dealing with the routine crisis of managing a city of 21 million people. Earthquakes, floods, traffic disasters, that was Maria's world. Then her phone rang. "Maria, this is President Hernandez. I need you to prepare for the largest evacuation in human history." Maria thought it was a prank call. Presidents don't personally call mid-level emergency coordinators. But then she turned on the news and watched the world change in real time. Within 48 hours, Maria was coordinating with emergency planners from every major coastal city on Earth. The impact zone, 600 kilometers south of Hawaii, meant tsunamis would hit every Pacific Rim country within hours. Wave heights of 100 meters were predicted for areas within 500 kilometers of the impact. Even conservative estimates showed walls of water 30 meters high, reaching as far as California, Japan, and Australia. 21 million people, Maria said during her first international planning call. That's just Mexico City. We're talking about evacuating the entire Pacific coast of 3 continents. The logistics was staggering. Tokyo alone would need to move 37 million people inland. Los Angeles, Seattle, Vancouver, Sydney, Manila, every major Pacific city would need to be emptied. In total, over 200 million people would need to be relocated at least 500 kilometers from the coast. But here's what nobody expected. People started moving before the governments told them to. Within a week of the announcement, real estate prices in coastal areas collapsed, while property values in places like Kansas, Nebraska, and the Australian outback skyrocketed. It was the largest voluntary migration in human history, driven not by government orders, but by basic survival instinct. James Wright was having a very different kind of crisis. As NASA's lead mission planner, he'd spent his career designing elegant, years-long spacecraft trajectories to Mars and beyond. Now he had 18 months to plan humanity's most desperate Hail Mary, a mission to deflect a 100-kilometer comet traveling at 60 kilometers per second. Impossible. He told NASA Administrator Chen when she first briefed him on the assignment. We'd need to change its velocity by at least 50 meters per second to make it miss Earth. That's like trying to stop a freight train with a firecracker. Figure it out, she replied. You have unlimited budget, unlimited international cooperation, and 18 months to save the world. So James got creative. Really creative. The plan that emerged from 6 months of intensive international collaboration was called Project Redemption. And it was unlike anything ever attempted. Instead of trying to destroy Atlas, which would just create millions of smaller impacts, they would try to nudge it. Just barely. Just enough. Picture this. Nuclear warheads detonated not on the comet, but near it. The idea was to use the energy from multiple nuclear explosions to heat one side of Atlas, increasing the outgassing that had caused the course change in the first place. But this time, the outgassing would be controlled, directed, designed to push the comet just slightly off course. The physics was staggering. Dr. Elena Santos at the European Space Agency calculated they would need the equivalent of every nuclear weapon on Earth, delivered to precise positions around Atlas over a period of 6 months. The margin for error was essentially zero. We get one chance, James explained to the international team of engineers now working around the clock in Houston, Moscow, Beijing, and Munich. If we miscalculate by even 1%, we either accomplish nothing or we break Atlas into pieces that will still hit Earth. The spacecraft they designed to carry this out was named Icarus, fitting, since humanity was flying closer to disaster than ever before. Actually, it was 6 spacecraft, each carrying 50 nuclear warheads and the most sophisticated guidance systems ever built. The mission would launch in 3 waves from different continents, arriving at Atlas 6 months before impact. But even as Project Redemption took shape, everyone knew it was a long shot. Maybe a 20% chance of success if everything went perfectly, which meant 80% of the world's resources were being devoted to survival. Dr. Michael Chen, no relation to the NASA administrator, was a geologist who found himself in charge of the most ambitious construction project in human history. His job was to build underground cities capable of housing 50 million people for up to 5 years. "We're not just talking about bomb shelters," he explained to his international team of engineers. "We're talking about complete underground ecosystems. Farms, factories, schools, hospitals. Everything humanity would need to survive a nuclear winter that could last decades." The construction sites were incredible to behold. In the Colorado Rockies, 10,000 workers were carving out caverns the size of football stadiums. In the Swiss Alps, entire mountains were being hollowed out and filled with hydroponic farms. Similar projects were underway in the Urals, the Andes, and the Himalayas. But the most ambitious project was happening in the Australian outback, where an international consortium was building what they called New Sydney, an underground city designed to house 5 million people indefinitely. Solar collectors on the surface would provide power, while massive air filtration systems would provide breathable air even if the surface atmosphere became toxic. "We're literally building the future of human civilization," Dr. Chen said. "These aren't temporary shelters. They're prototype colonies for a world that might be uninhabitable for decades." The engineering challenges were unprecedented. How do you provide fresh air for 5 million people underground? How do you grow enough food in artificial light? How do you maintain sanity and social order when humanity is reduced to cave dwelling? Solutions came from unexpected places. NASA's life support technology, designed for Mars missions, was scaled up for underground cities. The Netherlands contributed their expertise in below-sea-level construction. Japan provided seismic engineering to make the structures earthquake-proof, but perhaps the most important contribution came from psychologists and social scientists. Dr. Angela Morrison at Cambridge University was studying how to maintain human society under extreme stress. "We're not just engineering survival," she said. "We're engineering hope." The underground cities were designed with parks, theaters, schools, and even small zoos. Children born underground would never see the surface during their early years. So every effort was made to create environments that felt alive and hopeful, rather than like bunkers. Meanwhile, on the surface, something extraordinary was happening. Religious movements were spreading across the globe, but not the kind you might expect. Instead of doomsday cults, most focused on unity and preparation. The Church of Planetary Resilience attracted millions of followers with its message that Atlas was a test of human worthiness for cosmic citizenship. "We are being examined," preached Sister Mary Catherine from her cathedral in New York, which was being relocated stone by stone to underground chambers in upstate New York. "This is our final exam as a species. The question is not whether we will survive, but who we will choose to be in the face of extinction." The economic changes were just as dramatic as the social ones. Governments worldwide implemented what economists called survival capitalism. All industrial production was redirected toward impact preparation. Car factories retooled to produce air filtration systems. Smartphone manufacturers started making radiation detectors. The global economy restructured itself around a single goal: keeping humanity alive. And then there was Atlas itself, growing brighter in the sky each night. By January 2027, it was visible even in cities with heavy light pollution. By March, it was the brightest object in the night sky after the moon. Children pointed at it in wonder, not understanding they were looking at their potential destroyer. Amateur astronomers became celebrities overnight. Dr. Elena Vasquez, a high school teacher in Spain who had been photographing Atlas since 2017, found herself giving nightly updates on international television. "Look at how beautiful it is," she would say, pointing her telescope at the comet. Even our destroyer is magnificent, but Atlas was more than just beautiful, it was constantly changing. As it got closer to the sun, the outgassing increased. The tail grew longer and more spectacular, but it also made the comet harder to track precisely. Every night, astronomers had to recalculate the impact zone based on Atlas's latest behavior. It's like trying to predict where a rocket will land when someone keeps adjusting the engines, explained Dr. Chen, who had become the world's leading expert on Atlas after discovering its course change. By July 2027, 1 month before impact, Atlas dominated the sky. Its head was visible even during daylight, and its tail stretched across 90 degrees of sky at night. Photographers around the world captured images of this cosmic visitor that would become some of the most reproduced pictures in human history. The comet was so bright, it interfered with telescope observations. Streetlights became unnecessary. And most remarkably, its gravity was actually starting to affect Earth's tides. The difference was subtle, maybe a few centimeters, but it was measurable proof that Atlas was close enough to touch our world. Project Redemption launched its final mission on July 20th. 6. Icarus spacecraft, carrying humanity's last hope. The plan was elegant in its desperation. Detonate nuclear warheads around Atlas, in a carefully calculated sequence to nudge it just enough to miss. Earth, James Wright, watched the launches from Mission Control in Houston, knowing that everything, the underground cities, the evacuations, the survival preparations, all depended on whether his calculations were correct. 6 months of trajectory planning, thousands of variables, and millions of lives riding on mathematical models that had never been tested. Icarus 1 is away, came the announcement, as the first spacecraft began its journey to intercept Atlas. Then Icarus 2, 3, 4, 5, and 6. Humanity's most desperate gamble was finally in motion, but even as the Icarus fleet raced toward Atlas, everyone knew the odds. The mission might work, it might fail, it might succeed partially, breaking Atlas into smaller pieces that would still devastate the planet, which is why, on August 1st, with 12 days until impact, the largest voluntary migration in human history began. 200 million people moving inland, 50 million people moving underground, and 8 billion people preparing for whatever came next. Maria Rodriguez stood on the rooftop of her temporary command center in Guadalajara, 300 kilometers inland from Mexico City, and watched Atlas rise over the eastern horizon. Tomorrow, she would know if Project Redemption had succeeded. Tomorrow, she would know if humanity's greatest gamble had paid off. But tonight, she just watched our potential destroyer paint the sky with light and marveled at how beautiful the end of the world could be. Tomorrow, I'll take you inside those final 17 minutes as Atlas entered Earth's atmosphere. You'll experience the impact through the eyes of astronauts, survivors, and scientists who witnessed the moment that changed our planet forever. August 13th, 2027. 4:32 a.m. Greenwich Mean Time. Commander Sarah Kim is floating in the cupola of the International Space Station, 400 kilometers above Earth, when the sky tears open. She's been awake for 6 hours, along with her 5 crewmates, watching the Western Pacific for any sign of Atlas. Project Redemption's final status report came in 12 hours ago. 3 of the 6 Icarus spacecraft had successfully detonated their nuclear payloads around the comet. 3 had failed due to technical malfunctions. Was it enough? Nobody knew. The margin for error was so small that even a successful mission might only reduce the impact, not prevent it entirely. At 4:31 a.m. GMT, Atlas is still invisible, racing toward Earth at 60 kilometers per second from the direction of the sun. Then, at exactly 4:32, Commander Kim sees something that no human being has ever witnessed before. "My God," she whispers into her radio. It's like the sun is rising in the wrong place. 800 kilometers above the Pacific Ocean, Atlas slams into Earth's atmosphere. The comet, 100 kilometers, of ice and rock traveling faster than any bullet ever. Fired, suddenly encounters air, resistance for the first time in 12,000 years. The result is indescribable. Imagine a nuclear explosion. But instead of lasting milliseconds, it stretches across the entire western horizon. The leading edge of Atlas compresses the air in front of it so violently that the atmosphere itself begins to glow. Temperatures reach 50,000 degrees Celsius, 5 times hotter than the surface of the sun. Jesus Christ, it's bigger than anything. Commander Kim's transmission cuts off as the electromagnetic pulse from Atlas's atmospheric entry overwhelms the space station's communications. But she keeps watching. She has to. She's humanity's only witness to the most violent event in Earth's recent history. Atlas doesn't slow down as it hits the atmosphere. At 60 kilometers per second, air resistance is meaningless. The comet punches through Earth's entire atmospheric envelope, 100 kilometers of air from space to sea level, in exactly 8.7 seconds. Behind it, it leaves a tunnel of superheated plasma 40 kilometers wide and hundreds of kilometers long. The shockwave from this atmospheric compression races outward at the speed of sound, shattering windows in Tokyo 1,300 kilometers away before the comet even hits the water. Dr. Kenji Tanaka is in his seismology lab at the University of Tokyo when every piece of glass in the building explodes simultaneously. Not from the impact, that hasn't happened yet. Just from the light. The entire western sky just turned into the sun, he would later tell investigators. It was so bright it hurt to look at, even through the building's tinted windows. Then the light got brighter and brighter, and then the windows started melting. The electromagnetic pulse from Atlas's atmospheric entry knocks out power grids across the Pacific Rim. Satellites go dark. Communication networks fail. For the first time since the invention of radio, half the world goes silent simultaneously. But the show is just beginning. At 4:32 and 8.7 seconds GMT, Atlas hits the Pacific Ocean 637 kilometers south-southwest of Honolulu. The impact site is in water 4 kilometers deep, deep enough that under normal circumstances, anything falling into it would simply disappear into the abyss. Atlas is not normal circumstances. Moving at 60 kilometers per second, the comet doesn't splash into the ocean. It punches through it like it's tissue paper. The water doesn't have time to get out of the way. Instead, it's compressed, superheated, and instantly converted to steam. The impact creates a hole in the ocean 30 kilometers across and 10 kilometers deep, a crater that reaches all the way to the seafloor and keeps going, pouring into the Earth's crust like a cosmic drill bit. The energy release is 500 million megatons. To put that in perspective, that's more explosive force than every nuclear weapon ever built. Detonated simultaneously, then multiplied by 1,000. Commander Kim, still watching from the International Space Station, sees the flash first. A sphere of light brighter than the sun expands from the impact point, illuminating cloud formations 2,000 kilometers away. Then comes the shockwave, a perfect circle of disturbed atmosphere expanding outward like ripples on a pond. Except these ripples are moving at supersonic speed, and each one is tall enough to level mountains. The entire ocean It's gone, she radios to Mission Control, not knowing that Mission Control can't hear her anymore. There's just this massive crater where water used to be, and it's glowing like molten metal. What Commander Kim is seeing is the birth of the largest tsunami in recorded human history. The impact has displaced approximately 50 billion tons of seawater, launching it outward from the impact site at speeds approaching that of commercial aircraft. But this isn't like the tsunamis caused by earthquakes, where the wave height rarely exceeds 30 meters. The Atlas impact has created what oceanographers would later call a mega tsunami, a wave that begins at over 100 meters tall and maintains most of that height as it races across the Pacific Basin. The first wave reaches the Hawaiian Islands in 93 minutes. By then, most of the population has already been evacuated to higher ground, but a few dozen researchers and emergency workers remained behind to document the impact. Their final transmissions provide some of the only real-time accounts of what a 100-meter tsunami looks like up close. The wave it's not a wave, radios Dr. James Patel from his position on Mauna Loa, 2 kilometers above sea level. It's like a moving mountain of water. It's so tall, I can't see the top of it, and it's moving faster than anything should be able to move. Dr. Patel's transmission cuts off as the tsunami reaches the Big Island. When the water recedes 18 hours later, everything below the 500-meter elevation line is gone. Not damaged, gone. The wave has scoured the coastline down to bedrock, carrying away soil, vegetation, buildings, and everything else back out to sea. But Hawaii is just the beginning. The Atlas megatsunami is racing outward in all directions at close to the speed of sound. Automated buoys scattered across the Pacific, designed to provide tsunami warnings, register wave heights that break every scale they were designed to measure. Then one by one the buoys go silent as the waves consume them. The wave reaches Japan 7 hours after impact. Despite having 5 hours more warning than Hawaii, there's really nothing anyone can do. You can't outrun a 100-meter wall of water moving at jet speeds. The Japanese government's final official communication is a simple message broadcast on every emergency frequency. May Buddha protect us all. The west coast of North America has the most time to prepare, nearly 11 hours from impact to wave arrival. But preparation becomes meaningless when you're facing geological forces beyond human comprehension. Dr. Lisa Chen, yet another Chen in our story. But this one, a marine biologist at UC San Diego, is part of the skeleton crew that stayed behind to monitor the tsunami's approach. She's positioned 15 kilometers inland and 300 meters above sea level, supposedly safe from even the most extreme projections. I can see it coming, she radios at 3 p.m. Pacific time. It's like a moving cliff face stretching from horizon to horizon. The sound is, imagine every thunderstorm you've ever heard, happening at once, getting louder and louder. When the wave hits the California coast, it doesn't break like a normal wave. Instead, it simply rises, a vertical wall of water that climbs straight up the coastal mountains. Everything below the 200-meter elevation line disappears beneath churning black water, filled with debris, vehicles, and entire buildings tumbling like toys in a washing machine. But the most devastating effect isn't the water itself, it's what the water carries. The impact has pulverized the seafloor, launching billions of tons of sediment, rock, and organic matter into the atmosphere. This debris, superheated by the impact, begins falling back to Earth as what scientists would later call hypercane rain, precipitation so hot it ignites everything it touches. Within 6 hours of impact, forest fires are burning on every continent. The debris rain ignites the Amazon rainforest, the Canadian boreal forest, and the vast grasslands of Central Asia simultaneously. Smoke plumes visible from space begin rising from dozens of locations around the globe. Commander Kim, still orbiting Earth in the crippled International Space Station, watches in horror as her planet transforms beneath her. The fires are everywhere, she broadcasts to no one, since all communication networks remain down. Australia is burning. South America is burning. It's like the whole world is on fire, but the fires are just the visible part of the catastrophe. The real killer is invisible, the massive amount of vaporized seawater and pulverized rock that Atlas has injected into the atmosphere. Within 12 hours of impact, a cloud of debris 30 kilometers high begins spreading around the globe. This isn't just dust and steam. The impact has created something that has no precedent in human experience, an atmospheric mixture of superheated water vapor, pulverized rock, and organic compounds from the deep ocean floor. As this mixture begins to cool and condense, it starts falling as a rain unlike anything in Earth's geological record. The first reports come from ships in the Central Pacific that survived the initial tsunami. Raining mud, radios the captain of a cargo vessel 800 kilometers from the impact site. Black, sticky mud that's hot enough to burn skin. It's coming down so thick we can't see 10 meters in any direction. As the debris cloud spreads, the rain follows. First across the Pacific, then over Asia, Europe, and the Americas. Everywhere it falls, the superheated material ignites vegetation, melts plastic, and turns streets into rivers of steaming sludge. But perhaps the most ominous sign comes 15 hours after impact, when observatories in Chile, the only major telescope still functioning, report that the sun is no longer visible. The debris cloud has completely encircled Earth, blocking 90% of incoming sunlight. We've entered artificial winter, announces Dr. Maria Santos from the European Southern Observatory, broadcasting on one of the few remaining radio frequencies. Temperatures are already dropping. In some areas, we're seeing temperature decreases of 20 degrees Celsius in just 6 hours. The 17 minutes that began with Atlas entering Earth's atmosphere have triggered a cascade of effects that will reshape the planet for decades. The impact itself lasted only seconds, but its consequences are just beginning. Underground cities around the world seal their entrances as the toxic rain begins to fall. Surface facilities shut down their air intakes as the atmosphere becomes unbreathable. And in the deep ocean, something extraordinary is happening at the impact site. The crater carved by Atlas has exposed Earth's mantle to the ocean for the first time in millions of years. Superheated magma is boiling seawater, creating massive steam plumes that stretch into the stratosphere. The chemical reactions between mantle rock and ocean water are producing clouds of hydrogen, sulfide, methane, and other gases that will alter Earth's atmospheric composition for centuries. But hidden within this catastrophe is something unexpected. Atlas itself, the destroyer of our world, has also delivered something precious. Spectroscopic analysis of the impact debris reveals organic compounds more complex than anything found naturally on Earth. Amino acids, nucleotide bases, and long-chain carbon molecules that shouldn't exist outside of laboratory conditions. It's like Atlas was carrying a chemistry set. Dr. Chen at Beijing University explains to the handful of scientists still monitoring from underground facilities. The same impact that's destroying our ecosystem is also seeding it with the building blocks for entirely new forms of life. Commander Kim makes her final transmission 19 hours after impact, as the space station's life support systems begin to fail. Earth doesn't look like Earth anymore, she says into the darkness. The oceans are black, the continents are burning, and the sky is the color of rust. But it's still beautiful. It's still home. The 17 minutes that began at 4:32 a.m. GMT on August 13th, 2027, have ended the world as humanity knew it. But as Commander Kim suspected, they've also begun something new, something unprecedented in Earth's 4 billion-year history. The age of Atlas has begun. Tomorrow, I'll take you into the strange new world that emerged from this catastrophe, a planet wrapped in perpetual twilight, where new forms of life are already beginning to adapt to conditions that would have been impossible just days before. 6 months after impact, Dr. Anna Petrov emerges from the Siberian Research Complex into a world that no longer resembles the planet she left behind. The first thing that hits her is the silence. Not the peaceful quiet of a winter morning, but the profound, unsettling silence of a world where most of the animals are dead. No birdsong, no insect hum, just the whisper of wind carrying particles of ash and the distant rumble of volcanic activity triggered by the impact. The second thing she notices is the light, or rather, the lack of it. At what should be noon on a clear day in March, the sky glows with the dim orange radiance of perpetual twilight. The sun, when it's visible at all through the dust-laden atmosphere, appears as a faint disk barely brighter than the full moon used to be. Day 37 of surface observations. Anna speaks into her recorder. Her voice muffled by the breathing apparatus she'll need to wear outside for the rest of her life. Atmospheric dust levels remain at 60 times normal. Surface temperature negative 18 degrees Celsius. That's 42 degrees. Below the historical average for this date and location. Anna is one of only 300 scientists worldwide who have been authorized to make regular surface excursions from the underground facilities. Her mission is both simple and profound, to document how life on Earth is adapting to conditions that haven't existed since the last great extinction, 66 million years ago. What she's discovering is rewriting everything we thought we knew about life's resilience. The landscape around the Siberian complex used to be endless forests of pine and birch stretching to the horizon. Now it's a moonscape of ash-covered ground, punctuated by the blackened skeletons of trees. But as Anna walks through this apparent wasteland, she notices something extraordinary. "There," she whispers, kneeling beside what looks like a dead tree stump. "Growing in the ash layer, some kind of fungal network I've never seen before." What Anna has discovered is that fungi, often forgotten in discussions of life on Earth, are inheriting the planet. The massive die-off of plant and animal life has created the largest feast in fungal history. Dead forests spanning entire continents are being rapidly decomposed by fungal networks that are spreading faster than anything in the fossil record. But these aren't ordinary mushrooms. The fungi adapting to post-Atlas Earth are developing capabilities that seem almost alien. Some species are bioluminescent, glowing with an eerie blue-green light that helps them navigate the perpetual twilight. Others have developed the ability to digest materials that would have been toxic to their ancestors. Plastics, metals, even radioactive isotopes from the damaged nuclear facilities. The fungal mats are incredible, Anna explains in her weekly transmission to the other underground complexes. They're not just decomposing organic matter. They're actually concentrating and processing the mineral content from Atlas debris. It's like they're mining the impact fallout and converting it into bioavailable nutrients. 3,000 kilometers away, in the underwater research station off the coast of what used to be Japan, marine biologist Dr. Yuki Sato is documenting an equally dramatic transformation of Earth's oceans. The impact crater, still glowing with residual heat 6 months later, has fundamentally altered global ocean currents. The massive displacement of water has created new circulation patterns that are carrying nutrient-rich impact debris to every corner of the planet's oceans. We're seeing species that shouldn't exist. Dr. Sato reports during one of his deep-sea observation dives. Jellyfish with tissue structures I've never encountered. Bacteria that seem to be thriving in water temperatures that should kill everything. And the bioluminescence. It's like swimming through liquid starlight. The ocean creatures adapting to the post-impact world are developing traits that seem pulled from science fiction. Jellyfish populations have exploded, but these aren't the simple creatures we knew before Atlas. They've developed complex neural networks that allow them to hunt cooperatively. Some species have grown to the size of small whales, while others have developed the ability to survive in near-freezing water by generating their own body heat through bioluminescent chemical reactions. But the most remarkable discovery comes from the impact crater itself. Despite being ground zero for the most violent event in recent planetary history, the crater has become a hotbed of biological activity. The water temperature at the crater's edge is still nearly boiling, Dr. Sato explains. But life is thriving here. We're finding bacterial colonies that are using the heat energy from the impact to fuel chemical processes we've never seen before. They're literally eating the energy left behind by Atlas. These extremophile bacteria aren't just surviving in the hellish conditions around the impact site. They're flourishing. And more remarkably, they're producing complex organic compounds as waste products. Amino acids, sugars, and even primitive proteins are being manufactured in abundance by organisms that are using the impact's residual energy as a power source. Underground, In the vast cavern complex beneath the Rocky Mountains, agricultural engineer Dr. Chen is solving the puzzle of how to feed 50 million people in a world where surface agriculture is impossible. Traditional farming is dead. Chen explains to his team of hydroponics specialists, surface soil is contaminated with impact debris, temperatures are too low for most crops, and we have maybe 10% of normal sunlight. We're literally starting over. But starting over has led to innovations that might never have been developed under normal circumstances. The underground farms are using geothermal energy tapped from Earth's core, heated by the same forces that created the impact crater. LED arrays, powered by fusion reactors, provide the specific wavelengths of light that plants need for photosynthesis. Most remarkably, Chen's team is experimenting with crops that have been genetically modified, using samples from Atlas itself. The organic compounds detected in the comet's debris include proteins and enzymes that don't exist naturally on Earth. By incorporating these alien biochemistries into terrestrial plants, they're creating hybrid crops that can thrive in the low-light, low-temperature conditions of post-impact Earth. We're growing tomatoes that photosynthesize in near-infrared light, Chen says, showing off plants that look more like alien specimens than Earth vegetables. Potatoes that can survive temperatures that would have killed their ancestors. Wheat that actually thrives on atmospheric dust particles, but perhaps the most profound changes are happening in places where no human eyes can see them. In the deep ocean trenches, around underwater volcanic vents, and in the lightless caves where Earth's most ancient life forms have always hidden. Something unprecedented is occurring, Dr. Elena Rodriguez, monitoring these environments from her underwater laboratory, has detected what she calls accelerated evolution, species adapting to the new conditions not over millions of years, but over months. We're seeing genetic changes happening in real time, she explains during one of her rare surface communications. Bacterial populations are developing entirely new metabolic pathways. Fish species are modifying their sensory organs to navigate in near-total darkness. It's like evolution has shifted into overdrive. The key seems to be the complex organic compounds that Atlas delivered to Earth's biosphere. These alien molecules are acting as evolutionary catalysts, providing new biochemical tools that Earth's life forms can incorporate into their own biology. Atlas wasn't just a destroyer, Dr. Rodriguez realizes. It was also a delivery system. It brought us 4.5 billion years of cosmic evolution, compressed into one massive chemical package. The evidence is everywhere. New species of bacteria that can survive in pure sulfuric acid. Plant variants that photosynthesize using chemical energy instead of sunlight. Marine organisms that have developed primitive but functional electromagnetic senses. But the most remarkable discovery comes from Dr. Petrov's ongoing studies of the Siberian fungal networks. After months of observation, she's realized that these organisms aren't just decomposing the dead world, they're actively terraforming it. The fungal mats are concentrating minerals from the impact debris and depositing them in specific patterns, she explains. They're creating soil conditions that will be ideal for plant growth once the atmospheric dust clears. It's like they're preparing the ground for Earth's next chapter. The fungi are doing something even more extraordinary. They're actively filtering the atmosphere. The massive networks spreading across the dead continents are absorbing toxic compounds from the air and converting them into harmless organic matter. In essence, they're cleaning up the damage from the impact while simultaneously preparing the foundation for whatever life forms will dominate the recovering planet. 8 months after impact, the first green shoots appear in the volcanic soil of the Pacific Northwest. Not recognizable plants, but something new, hybrid organisms that seem to combine characteristics of plants, fungi, and bacteria. They photosynthesize in the dim light, but they also derive energy from decomposing organic matter and chemical reactions with impact debris. Life is figuring it out, Dr. Petrov observes, as she documents these first pioneers of the New World. It's not the same life we knew before, but it's life nonetheless. And it's beautiful in its own way. The new plants glow faintly in the perpetual twilight, their bioluminescent cells making them visible against the ash-covered landscape. Their leaves are thick and waxy, designed to capture every photon of available light, while protecting against the harsh chemical composition of the post-impact atmosphere. As the first anniversary of Atlas approaches, something remarkable happens. The constant global dust storms that have raged since the impact begin to calm. The atmospheric debris, much of it now filtered and processed by the expanding fungal networks, starts to settle. For the first time in a year, observers in the underground complexes report seeing actual blue sky through the observation domes. The sun, when it finally breaks through the clearing atmosphere, illuminates a world transformed beyond recognition. Coastlines have been redrawn by the mega tsunamis. Mountain ranges have been carved into new shapes by the hypercane rains. Entire ecosystems have been replaced by fungal networks that glow softly in the darkness. But most remarkably, life is everywhere. Not the life that existed before Atlas, but new forms of life that are perfectly adapted to the conditions the impact created. The planet hasn't died. It has evolved into something unprecedented in its 4-billion-year history. We're living in a science fiction movie. Dr. Chen observes as he watches bioluminescent plants spreading across the landscape, visible from his underground observatory. But maybe that's what evolution always looks like when you're watching. It happened in real time. The children born in the underground cities during that first year after impact will never know the world that came before. To them, glowing forests and luminescent oceans will be normal. Fungi the size of trees and jellyfish. The size of whales will be the natural order of things. They are the first generation of humans adapted to life on the new Earth, a planet that Atlas destroyed and simultaneously reborn. And as they take their first steps onto the transformed surface, they're walking into a world where the impossible has become everyday reality. Tomorrow, I'll tell you about those children, the first generation to grow up in humanity's new home among the stars, because the transformation of Earth was just the beginning of what Atlas made possible. 20 years after Atlas changed everything, 16-year-old Chen stands on the observation deck of New Geneva Station, floating 300 kilometers above the transformed Earth, and watches her home planet turn slowly beneath her. Maya has never breathed unfiltered air. She has never felt rain on her skin. She has never seen a blue sky, because for her entire life, Earth's atmosphere has glowed with the soft orange radiance of perpetual twilight. This isn't a tragedy to her. It's simply the way the world is. "Look at that," she whispers to her friend David, pointing at the bioluminescent networks that trace glowing patterns across the night side of the planet below. The fungal networks in South America are spreading again. They'll probably connect with the Asian networks within the year. Maya speaks casually about things that would have seemed impossible to her grandparents' generation. To her, a planet covered in glowing organisms, floating cities in space, and regular travel between worlds is simply normal. Life. She represents something entirely new in human history, the first generation, born into what historians are already calling the cosmic age. These children don't think of themselves as living on Earth. They think of themselves as living in the solar system. Home isn't a planet. It's a civilization that spans multiple worlds. The numbers tell the story of humanity's transformation. 20 years after Atlas, only 2 billion people still live on Earth's surface. 3 billion live in the underground cities that have evolved from survival shelters into technological wonderlands. Another billion live in space, on stations like New Geneva, in lunar colonies, in the growing settlements on Mars and Europa. But the most important changes aren't in where humans live. They're in how they think. "We're gardeners now," explains Dr. Sarah Kim, the former International Space Station commander who survived the impact and now directs the Solar System Development Authority. "We don't just live in space, we cultivate it. We move asteroids like chess pieces. We maintain weather systems on terraforming worlds. And we've learned to see the entire solar system as our backyard. The technology that made this possible grew directly from the desperation of the Atlas crisis. The deflection systems designed to save Earth became the propulsion systems that carry humans to other worlds. The underground life support systems became the foundation for self-sustaining space habitats. Most importantly, the global cooperation forced by the impact threat created the first truly unified human government. Maya's daily routine would have seemed like science fiction to her parents' generation. She wakes up in her family's module aboard New Geneva Station, attends classes with students from 12 different worlds via quantum-entangled communication networks, and spends her afternoons working in the station's agricultural domes where food is grown in zero gravity using techniques developed in the post-Atlas underground cities. But what makes Maya truly representative of her generation is what's inside her head. Like all children born after Atlas, she carries neural implants that connect her directly to the deep space detection network, humanity's early warning system that monitors every object larger than a basketball throughout the solar system. I always know where everything is, Maya explains to her grandmother during one of their weekly video calls to the underground city in Colorado. Right now I can tell you the position and trajectory of 47,000 asteroids, 32 comets, and every piece of human-made debris larger than a coffee cup. It's like having a mental map of the entire solar system. This isn't just technological convenience, it's psychological transformation. The children of Atlas don't fear cosmic impacts because they're constantly aware of everything in space around them. They've grown up with the knowledge that humans can move worlds when necessary. Dr. Elena Santos, now 83 and one of the few scientists still alive who studied the original Atlas, spends her time documenting how profoundly the impact has changed human consciousness. Before Atlas, we thought of space as this vast, empty, dangerous place that we might someday explore, she explains. Now children grow up thinking of space as their natural habitat. They're not Earthlings who sometimes visit space. They're cosmic citizens who sometimes visit planets. The change is visible in how Maya and her generation approach problems that would have seemed insurmountable to earlier humans. When a rogue asteroid threatens the growing colony on Europa, Maya's class spends a week calculating deflection trajectories as a homework assignment. When solar flares disrupt communications between Mars and Earth, students like David design backup communication systems using gravitational wave detectors. We don't think in terms of surviving disasters, Maya says. We think in terms of managing the environment. If there's a problem with space weather, you adjust your orbital parameters. If an asteroid is in the wrong place, you move it. If a planet's atmosphere isn't right for human habitation, you fix it. This confidence comes from growing up in a civilization that has already survived the ultimate test. The children of Atlas have been raised on stories of how humanity mobilized to face extinction and not just survived, but emerged stronger. To them, there's no problem too large to solve. The proof is everywhere. The Asteroid Management Division employs 30,000 people whose job is literally to reorganize the solar system for human convenience. Mining stations harvest ice from comets to provide water for Mars colonies. Automated systems patrol the space between worlds, constantly adjusting the orbits of potential threats. But perhaps the most remarkable change is how humans now think about Earth itself. The planet that was nearly destroyed by Atlas has become something precious and unique, not because it's where humans live, but because it's where humans evolved. Earth is our museum now, explains Dr. Chen, who at 91 still oversees agricultural development in the underground cities. We're restoring it, not because we need to live there, but because it's our heritage. The glowing forests, the bioluminescent oceans, the hybrid ecosystems, they're all part of Earth's story now. And we're the curators of that story. The restoration project has become the largest cooperative effort in human history. Space-based solar collectors beam energy to Earth to power massive atmospheric processes that are slowly clearing the remaining impact debris. Genetic engineering techniques developed for off-world agriculture are being used to help Earth's hybrid ecosystems stabilize and flourish. Most remarkably, humans are choosing to preserve many of the changes that Atlas created. The bioluminescent forests have proven to be more efficient at carbon processing than the original ecosystems. The fungal networks that spans continents are better at soil regeneration than anything that existed before the impact. The hybrid marine life is more resilient to temperature changes and chemical variations. We're not trying to restore the old Earth, explains Maya during a presentation to her environmental science class. We're trying to optimize the new one. Atlas didn't just destroy our old world. It gave us the raw materials to build a better one. This perspective, that catastrophe can be the foundation for improvement, defines the post-Atlas generation. They don't see the impact as a tragedy that humanity survived, but as the catalyst that transformed the species into something capable of thriving in the cosmos. The evidence of this transformation is written in the stars themselves. Humans now maintain permanent settlements on 17 different worlds. The population of Mars has reached 50 million. Europa's underwater cities house another 20 million. Even Venus, once considered impossible to inhabit, now has floating cities in its upper atmosphere, where pressure and temperature conditions are manageable. But the most audacious project is the construction of New Terra, an entirely artificial world built from asteroids and comets at the L4 Lagrange point between Earth and the Moon, with a surface area larger than Australia and a population approaching 100 million. New Terra represents humanity's first attempt to build a world from scratch. We're not explorers anymore. Maya observes as she watches construction ships adding new sections to New Terra's rotating habitation rings. We're builders. We don't just visit other worlds, we make them. The children growing up on New Terra will be even further removed from the original Earth experience. They'll live under artificial skies that can display any weather pattern the inhabitants choose. They'll breathe air that's cleaner than anything that ever existed naturally. They'll look up at night and see stars that are actually other human settlements scattered across the solar system. Maya's younger brother Alex, born on New Terra and now 12 years old, has never set foot on a natural planetary surface. When he talks about going outside, he means stepping out of the habitat modules onto the observation decks of the artificial world where he was born. Alex thinks gravity is something you adjust with dials, Maya laughs. When he visits us on New Geneva, he's constantly trying to figure out why the gravity controls aren't working properly. He can't understand why we can't just turn it up or down as needed. This is the new normal for humanity's children. A universe where physical laws are constraints to be managed, not limitations to be accepted. They've grown up with technology that can move planets, redirect comets, and build worlds from cosmic debris. To them, the question isn't whether humanity can solve a problem, but simply how long it will take. The psychological impact of this transformation reaches far beyond technology. The children of Atlas approach life with a confidence that would have seemed arrogant to earlier generations, but which makes perfect sense given their experience. They've grown up in a civilization that literally rebuilt itself after near extinction. They've watched their parents and grandparents turn a disaster that should have ended human history into the foundation for cosmic expansion. We don't really understand fear the way older generations do. Maya explains, during one of her regular interviews with historians documenting the post-Atlas transformation. When adults talk about things being impossible or too dangerous, we don't really get it. Dangerous compared to what? Too expensive compared to rebuilding an entire civilization. We've already done the hardest thing imaginable. This fearlessness is reshaping human ambition in ways that are just beginning to become apparent. Maya's generation is planning missions to other star systems, not as distant dreams, but as practical engineering projects. They're designing technologies to terraform entire planets. They're seriously discussing how to manage the energy output of stars. Atlas taught us that we're not passengers in the universe, Maya says, as she watches the stars wheel slowly past the observation deck of New Geneva Station. We're active participants. We can change things. We can make things better. As the 20-year anniversary of the Atlas impact approaches, humanity is preparing for the largest celebration in its history. Not mourning for what was lost, but celebrating what was gained. The impact that should have ended human civilization instead transformed it into something unprecedented in the galaxy's history. Earth still bears the scars of that terrible day. The coastlines remain redrawn by the mega-tsunamis. The impact crater is now a glowing lake of mineral-rich water that serves as a reminder of how close humanity came to extinction. The bioluminescent forests and hybrid ecosystems create landscapes that would have seemed alien to previous generations. But to Maya and her generation, these aren't scars. They're decorations. Earth isn't a wounded world struggling to recover. It's the proof that life can transform even the most devastating catastrophe into an opportunity for growth. Sometimes I wonder what would have happened if Atlas had missed us, Maya says. Her neural implants automatically tracking the positions of 3 newly discovered comets in the outer solar system. Would we still be stuck on one world, fighting over resources, believing that space exploration was too expensive or too dangerous? Would we still think of ourselves as separate nations instead of one species? The answer, according to the historians and sociologists studying the post-Atlas transformation, is almost certainly yes. The impact forced humanity to unify in ways that centuries of diplomacy had failed to achieve. The underground cities broke down national boundaries permanently. When you're sharing air recyclers and food production with people from around the world, nationality becomes meaningless. But more than that, Atlas gave humanity something that no species in galactic history has ever possessed: advance warning of extinction and the time to prepare for it. Most civilizations that face cosmic impacts either have no warning at all, or have warning but lack the technology to respond. Humanity had 2 years to mobilize every resource, every brilliant mind, every innovative solution on the planet. We got lucky, admits Dr. James Morrison, now directing the Galactic Survey Project from his office on Luna Prime. If Atlas had been discovered just 6 months later, we wouldn't have had time to build the underground cities. If it had been discovered 6 months earlier, we might not have had the technology to detect the course change. The timing was perfect for transforming catastrophe into opportunity. The children of Atlas understand this historical accident, but they've drawn a different conclusion from it than their parents might expect. Instead of feeling grateful for the luck, they've decided to eliminate the element of chance from human survival. Maya's generation isn't just monitoring the solar system, they're actively managing it. The deep space detection network that connects to their neural implants isn't just a warning system, it's a control system. Humans now track and can redirect any potentially dangerous object within 50 astronomical units of Earth. We're not waiting for the next Atlas, explains David, who at 17 is already designing propulsion systems for interstellar missions. We're making sure there never is a next Atlas, and if something does threaten us from outside our detection grid, we'll be ready to move our entire civilization out of the way. This confidence isn't theoretical. Humanity has already faced 3 potential impact threats since Atlas, and each one was redirected so efficiently that most people barely noticed. The asteroid management systems work so seamlessly that diverting a potential planet killer has become routine, something handled by automated systems with human oversight, like traffic control in the old days. But the most profound change isn't in humanity's technology, it's in how the species thinks about itself. The children of Atlas don't see humans as a planetary species that sometimes travels to space. They see humans as a cosmic species that happens to have originated on one particular world. Earth is where we came from. Maya explains during a philosophy class conducted simultaneously across 12 different worlds. But the solar system is where we live, and the galaxy is where we're going. This shift in perspective has consequences that extend far beyond space exploration. When your identity is cosmic rather than planetary, problems that seemed insurmountable to earlier generations become engineering challenges with known solutions. Climate change. Humans now manage the atmospheric composition of 14 different worlds, including Earth. Resource scarcity. The asteroid belt contains more metal than humanity could use in 1,000,000 years. Energy shortages. Solar collectors in space provide unlimited power to every human settlement. We've basically solved all the problems that defined human history, observes Dr. Elena Rodriguez, now 94, and still studying the transformed ecosystems of post-Atlas Earth. Poverty, hunger, resource conflicts, even death from aging. We've developed solutions for all of them. The children of Atlas are growing up in a post-scarcity civilization. The life extension technology deserves special mention. The same biotechnology that allowed underground cities to support human life for years in artificial environments has been refined to extend human lifespan indefinitely. Maya's generation expects to live for centuries, maybe millennia. They're planning their lives and careers on timescales that would have seemed impossible to their ancestors. I'm going to spend the next 50 years learning how to terraform gas giants, Maya says casually. Then maybe a century exploring other star systems. After that, I'm thinking about taking up music composition. I've got time. This extended lifespan has profound implications for human knowledge and culture. Instead of each generation having to relearn everything from the beginning, accumulated expertise can be maintained and expanded over centuries. Scientists can pursue research projects that take decades to complete. Artists can develop their skills over lifespans that dwarf the entire careers of historical masters. But perhaps the most remarkable aspect of the post-Atlas transformation is how it's affected human relationships with other forms of life. The hybrid ecosystems created by the impact have taught humanity that intelligence and consciousness can take forms radically different from anything that existed before Atlas. The fungal networks that span continents display behaviors that suggest they might be conscious in ways humans are only beginning to understand. The hybrid marine life in Earth's transformed oceans has developed communication systems of bioluminescent patterns that rival human language in complexity. Some of the bacterial colonies in space habitats seem to respond to environmental changes in ways that suggest collective decision-making. We're not alone anymore, Maya observes as she watches a pod of the giant luminescent jellyfish that now migrate between Earth's oceans and the water-filled caverns of Europa. Not because we've found aliens, but because we've helped create new forms of intelligence right here in our own solar system. This expanded definition of life and consciousness has become central to how humanity approaches its cosmic expansion. Instead of seeing space as empty territory to be conquered, Maya's generation sees it as an environment to be cultivated, a place where new forms of life and intelligence can be nurtured into existence. The implications are staggering. On Mars, carefully managed bacterial colonies are transforming the atmosphere at a rate far faster than any natural process. On Europa, hybrid organisms developed from Earth's post-Atlas marine life are creating complex ecosystems in the Moon's subsurface oceans. Even in the vacuum of space, specialized organisms are being developed that can survive and thrive in conditions that would kill any natural life form. We're not just spreading human civilization across the galaxy, explains Dr. Santos during her final lecture before retirement. We're spreading consciousness itself. We're seeding the universe with intelligence in forms that never could have evolved naturally. As Maya prepares for her 18th birthday, and her transition to full adult citizenship in the Solar Federation. She represents something entirely new in galactic history, a member of a species that has consciously chosen to evolve beyond its original form. The neural implants that connect her to the deep space detection network are just the beginning. Her generation is experimenting with biotechnology that will allow humans to survive unprotected in the vacuum of space, to photosynthesize like plants, to hibernate for decades during interstellar journeys. We're not trying to stay human, Maya explains, as she undergoes genetic modifications that will allow her to process radiation like food. We're trying to become whatever we need to become, to thrive anywhere in the universe. This transformation isn't happening in laboratories. It's happening in the daily lives of children who think nothing of breathing water instead of air when they visit Europa, or adjusting their metabolism to function efficiently. In the low-energy environment of the outer solar system, the children of Atlas are becoming something unprecedented, a species that consciously guides its own evolution, that treats the fundamental constants of biology and physics as parameters to be optimized, rather than limitations to be accepted. 20 years after a comet nearly ended human civilization, Maya stands on the observation deck of a space station that houses 500,000 people, looks out at a solar system full of human settlements and hybrid life forms, and plans her career on timescales measured in centuries. She represents the first generation of true cosmic citizens, humans who have never known scarcity, never feared cosmic threats, never doubted that any problem can be solved given enough time and resources. They've grown up in a civilization that rebuilt itself from near extinction into something that spans multiple worlds and multiple forms of consciousness. Atlas wasn't our destroyer, Maya says, as she watches the transformed Earth rotate slowly beneath her, its bioluminescent networks pulsing with life that didn't exist 20 years ago. Atlas was our teacher. It taught us that we're not victims of cosmic forces, we're partners with them. It taught us that destruction and creation are the same process, just viewed from different perspectives. As she speaks, her neural implants detect a new object entering the solar system from interstellar space. Not a threat. The automated defense systems have already calculated that it will pass harmlessly beyond Neptune's orbit. But Maya finds herself hoping it's another comet, another carrier of cosmic chemistry that could seed new forms of life and intelligence in humanity's expanding garden, because Maya and her generation understand something that no previous humans could have grasped. Sometimes the greatest gifts come disguised as the greatest threats. Sometimes destruction is just another word for transformation, and sometimes the end of the world is really just the beginning of something better. The children of Atlas have inherited a universe full of possibilities, and they're just getting started.